thank you very much. And also hello to everyone from my side. My name is Momchuk Binev. I'm a senior product manager at the Imaging Source. And this session is about embedded system design and the top challenges, starting from the sensor to the final application and the possible solutions that we can offer. I'm going to start with a very short introduction to embedded vision and clarifying some of the buzzwords. We typically speak about integrating of computer vision into embedded vision systems. We speak about usually using specialized computing devices like DSPs or FPGAs or GPUs to perform our dedicated tasks. This is completely different from using a general purpose CPU on a workstation. This, of course, involves always the capturing of image data, processing, interpretation of the data, and it could be done directly on the camera, for example, if you're using cameras, of course, or on the robot or drones or any other devices. And we typically don't rely on external computing power, but try to complete everything on the edge device. So what are the typical key components of an embedded vision system? Of course, we have sensors. This could be also image sensors, but any other sensors either. When we speak about visualizing data, it is typically an image sensor, and it could be the sensor itself, or it could be a sensor integrated onto a camera module and providing more functionality. Then, of course, we have the processors that perform the image processing. And as I said, we are using here dedicated hardware that is designed for executing some dedicated task. It could be microcontroller, it could be ISP, DSP, FPGA, or GPU. Then we, of course, have the algorithms that have to process this image data. And last but not least, of course, software frameworks. And here I have listed some, let's say, pure general open source frameworks like GStreamer, OpenCV, or TensorFlow when it's about AI. Or, of course, some proprietary frameworks like DeepStream from NVIDIA or NNStreamer from NXP. And what are the typical applications? However, this is just a fraction of possible applications that you can come across when I speak about embedded vision. Surely starting with automotive, industrial automation with robotics, with quality control, and so on. Healthcare or life sciences, typically with patient monitoring or diagnostics tools, and so on. Then surely consumer electronics with face or gesture recognition, augmented reality, and so on. And retail, any kind of smart checkout systems. But surely, as I said, drone applications, agricultural applications, and so on and so on. What I obviously didn't mention explicitly, but it's, I think, clear. We speak about a small, compact, lightweight, low power consumption, and very cost-effective systems. So this is what the customers typically expect. So by that, I'm coming to the top challenges. And again, these are just a fraction of the typical challenges that you can come across in a project development. And we probably need a few days or weeks in order to cover all of them in detail. So that's why I'm going just to highlight some of them and focus on only one today. Starting with the device compatibility. Yeah, imagine we have different system on model chips. We have different carrier boards because you need the carrier board to connect your cameras or peripheral devices. We surely have the board support packages for those carrier boards and zones, but we also need the device drivers. In cases you are using technology based on serialized or deserialized, of course, you need an extra board to connect these cameras to. And not to forget, of course, software packages, especially when we speak about NVIDIA and Jetpack versions. This could have, of course, a big impact on your application. So next one, I mentioned it, we're using specialized computing hardware, and it's always a topic in embedded vision, of course, the power consumption, because unlike a general purpose CPU, which is consuming a lot of power, in these cases, we are looking probably for less than one hundredths of the power that the CPU consumes. And of course, this specialized hardware needs to be optimized and calibrated in the right way so that it does the job. Next one is memory footprint. Of course, when speaking about embedded vision, it is not easy to upgrade, let's say, the DRAM if you later figure out that your image processing requires more power. So this is something that you really have to consider in a very early phase of your project. And of course, even if physically possible to upgrade the DRAM, this could introduce some constraints to your system, for example, system latency. Of course, the weight, the size, and the size of the system and so on will be also introduced, also impacted by that. But this is, as I said, in most of the cases, actually, you cannot do it simply. Bandwidth issues is, well, something about to consider when you have maybe also multiple cameras that are remotely connecting image data. And it's always the question, do you process this data closer to the camera, or you want to transfer this data maybe to a centralized processing unit, or even to the cloud? And this, of course, depending on the design decision, it could introduce at some point also some bandwidth issues. Definitely something to consider. Security issues. Yeah, I think drone applications are very popular in the past years and nowadays either. Here we typically speak about detection of tampering, and then of course introduction of some security communication features. But this comes at some certain cost, yeah, to your system, and of course it can run your system into some physical constraints. Definitely something to consider, not in all cases, but in depending on the application. Algorithms and optimization. All the processing algorithms, or most of them, have been originally developed on workstations and for running on general purpose CPUs. So if customers sometimes expect just to take them and let them run on this dedicated hardware, and have the same results, this is typically not the case. So you have to spend definitely some time on optimizing these algorithms to do the job on your specific hardware. Compliance and certifications, it sounds trivial, and sometimes probably it is also trivial if both parties, let's say sensor or camera manufacturer and an OEM, know who is responsible for what and what kind of certifications are needed for the given application or maybe for the given country. So sometimes it's a really trivial story, but sometimes it could be simply a showstopper at the end. So something definitely to consider maybe in the very beginning of your development. And last but not least, I call it prototyping costs. It's always also the question, customers typically have the expectation that they are saving money, surely, yeah, and this is the final expectation of the system. But the question is how much it costs in the development phase, and do you have also a prototyping phase? I personally call it a feasibility phase. I would definitely recommend not to start with the project development and be negatively surprised by maybe by the middle or the end of the project when you face some problems that you cannot fix. I would instead go for a prototyping phase and try to figure out what are the main challenges or constraints that I have to deal with later on. Of course, you cannot prototype everything, but it's always finding the right trade-off between prototyping and then starting a real project. So as I said, we can spend probably weeks on speaking on all of these points in detail. Today, I'm going to focus on the device compatibility. So basically on the first point that I presented here. So when speaking about this, we have many things to consider. I mentioned some of them, but now I'm going to go into a greater detail now, starting with cameras. And of course, then we speak about interfaces. Yeah, sometimes and I think I heard it somehow today also, when speaking about embedded, some people think about MIPI CSI2 only, but it's not only. Of course, we have technologies that are based on MIPI CSI2, like GMSL2 or FPD-Link, that use a deserializer technology to extend the cable length, and that are definitely more suitable in harsh environments. But embedded vision could be also USB and GIGI, exactly the same way. So it depends really on the application, on your requirements, and what is eventually doing the job for you. So I would really always in customer talks would try, and I'm doing it all the time, to figure out what is actually the problem to solve, and not what is the solution before we have spoken about the problem. Then accessories sounds trivial, but sometimes it's not, especially when we're using those kinds of technologies like GMSL2 or FPD-Link that require the deserializer boards. Of course, this introduces an extra complexity to the system, and it's also about developing the right drivers for it. Lenses is also trivial, but probably not when we speak about IP67 protection and when customers probably expect like fisheye lenses and probably covering 180 degrees field of view. This is not working. Yeah? So this is a lot of consultancy in the beginning of the project to figure out what are the right requirements for the given use case. Cables, same story, could be trivial like FFC or coaxial cables, but when we speak about IP67 and maybe let's say about GMSL2, then you have a different complexity that you have to consider. So speaking about platforms, I'm here mentioning just some of them. There are surely many more outside on the market, but let's say focusing on the most popular ones, definitely NVIDIA, NXP, and Raspberry Pi. You need career boards from them. And having career boards, it's also the question, can you find a company or a partner that can develop or that maybe have off-the-shelf career board for your use case, or you need to develop an extra career board for your application? This, of course, introduces again a completely new complexity to the project, and this is something that is ideally to figure out in the beginning and not maybe in the middle or the end of the project. And when speaking about these platforms, of course, we have to speak about software, because having a ZOM, a system model with a career board, means that you have to have also board support package for it. And the board support package is bringing the operating system with the drivers for the peripheral devices, but of course you have to take care about providing the drivers for the cameras, for the given career board and the given operating system and zone. So this is not to underestimate for sure. Of course, speaking about SDKs and in most of the cases, we use open source, but not always. It depends again on the customer requirements. And of course, everyone wants to protect his IP and maybe to develop something unique. This is definitely a very important topic to consider. So you see, in this combination of hardware, software, platforms, everything must be calibrated and working together so that the application is doing the job eventually. Sounds trivial, but it's typically not. So going further and looking into the separate areas, I would like again to point out that starting with the cameras, it's, as I said, not always only MIPI CSI2. It could be also gigabit Ethernet, and I'm here showing our 47G series, which is also an embedded camera. We perceive it this is an embedded camera with power over Ethernet and giving you exactly the flexibility to integrate this camera into a bigger machine. So, of course, MIPI CSI2, clear. And then technologies based on MIPI CSI2, FPD-Link, and then GMSL2, coming with board level version and also optionally as IP67 housing, then including lens, including cable and everything in order to run them in the final solution. And last but not least, USB 2 or USB 3, both. It depends on the use case. If USB and Gigi are doing the job, we speak about plug-and-play interfaces. That means you don't have to spend so much time on the development, on getting these cameras up and running. Just you can focus immediately on your, let's say, core know-how, the image processing or building the system. When you decide to go for, let's say, the low-level interfaces, MIPI, GMSL2, and FPD-Link, you have to spend more time on the development of the drivers and getting these cameras up and running and getting the right image quality before you can focus on your know-how, core know-how. So this is definitely something to consider. So once again, embedded vision means ZOMs, so system on models, career boards for all the peripheral devices. And I just want to highlight once again, if you are going for this, let's say 15 meters of cable length with GMSL2 or FPD-Link, then of course you have to consider deserializer boards too. Then embedded platforms, I think I'm not saying anything new today, but just to give you our perspective on the pros and cons of, let's say, of NVIDIA and NXP. Of course, NVIDIA, we support both Orin and Xavier, and the pros are obvious. Of course, NVIDIA is doing the best high processing or the best image processing, capabilities with also the best AI feature sets, sure. On the con side, surely the price. I mean, this best performance has its price. The product life cycles are, let's say, not so long, not these kind of industrial grade that we expect in the let's say in the machine vision market. And last but not least, the Jetpack version. So I think we all know that especially developers, of course, have their hard time with different JPEG versions and getting especially the device drivers running again. So this is definitely something that should not be underestimated for sure. Yeah. Then on the other side, NXP, and here the example for IMX8M Plus. It depends on the application, but let's say if we generally look at the applications, we can say that NXP is providing the best price performance ratio. Also these long product life cycles, like 10 plus years. On the other side, definitely lower processing power and lower AI performance in comparison to NVIDIA, surely much better than Raspberry Pi, but comparing to NVIDIA, definitely much lower performance. And what I think is very important for those applications that require multi-camera support, we can run only 2 MIPI cameras on an XP, or exactly the same, only 2 GMSL2 or FPD-Link cameras. So definitely something to consider. When we speak about multi-camera applications in NVIDIA, then you can easily go for 4 and even more cameras. Then the good thing is that we, the imaging source, provide reference designs for both platforms. And I'm not speaking only about development kits, we're speaking also about designs for the mass production. Yeah. And by that, I'm coming to my last slide, actually. And this is the sub-headline of this session. So how we come from the sensor to the application, because the application is actually where we see the customer know-how and his core know-how, where he starts actually building the image processing and then the system. So starting with the sensors. So we always try to focus on, of course, popular sensor manufacturers, but not only. We're definitely very curious about new sensor manufacturers, or maybe sensor manufacturers coming from a vertical market. Yeah, and it is, as I said, in embedded visions, always, I think the first factor is the price. And of course, we can integrate also very expensive sensors on these kind of interfaces, but typically the price is really the key factor in such cases. So then we integrate those sensors, of course, into camera boards and, of course, offer them with different interfaces. I mentioned today already GIGI, USB, MIPI, GMSL2, and FPD-Link. Of course, board level housing, IP67 protection. Then going to the accessories, as I said, sounds trivial. Sometimes it's not. Providing the right deserializer boards for technologies that require that, the right cables for the given use case. Then going further, and I think this is startly getting clear that we go for more than just providing the cameras. We provide also the system on modules and carrier boards together with the cameras. And when you do so, you have to also provide the board support packages. That means operating system and also with the device drivers in order to get these cameras running. Last but not least, yeah, the right SDK. And demo application, so that actually you unbox this solution and you can, let's say, make a click on executable and get images and get these images also displayed. So that means the experience should be like as if you're using a standard GIGI Vision camera on a workstation. This is what we are targeting at, and definitely want to provide the complete solution and not only the single components. So that's it from my side. Thank you very much, and I'm looking forward to getting any questions.
What sensor vendors and sensor models do you support currently, and what are you planning to support next?
I mentioned it very shortly. Of course, we have Sony and onsemi, both global shutter, rolling shutter, but as I said, we are really trying to implement those sensors that are cost effective, because this shows to be really the showstopper in some applications, unless, of course, we are speaking about projects when customers need some, let's say, specific high resolution and expensive sensors. beg your pardon, I will not going to review the portfolio or our roadmap, but we're definitely, as I said, looking also at other sensor manufacturers that are maybe coming from vertical markets and provide a very interesting and price-sensitive sensors. So this is something that we're definitely doing also.
I'm a little bit curious. I was at your booth at the Vision and I saw you presented a USB 2 camera.
Yeah.
Why that?
This is very funny story. Of course, historically seen, we have been providing USB 2 cameras for many years. And this is not about the performance of USB, it is about the cost. And we know it in our industry, we have systems that are running definitely more than 10 years, in some cases even 15, 20 years. Of course, customers try to get these systems running even longer, which sometimes makes no sense and it's difficult to maintain. But yeah, we have a really high demand for USB 2, for replacement for the old USB 2 cameras. So we decided to go this way and provide a kind of new generation of USB 2 cameras. It's nothing innovative, but definitely the technology that we use is future-proof. So we can provide it even for the next 10 years.
And if the customer needs it, it's good.
It's always economical perspective and of course the feasibility point, but yeah, we had a really high demand and high request from our customers. So this was the reason to do it.
So thanks a lot for your presentation. I will see you at the Q&A section. And now we go on to our last presentation for the session.